So what happens if n equals 1? Well, if n equals 1, then we consider same contour as when n equals 0. Again, f is not even, assuming f is not even and has no branch cuts, then we consider r goes to infinity, epsilon goes to 0, the contour integral of log squared of z. Okay, so what's that going to give? So first along here we'll get I2. Around here let's just assume that we'll get 0. Back along here, that's the interesting bit. So back along here we'll get the integral from infinity to 0 of f of z times log of, f of x, log of x plus I2 pi. Now this is now squared dx. And then the last bit, again, we're going to assume, hopefully, depending on f, that we'll get 0. That's not always the case, but the purpose of this, we'll just take it as being 0. Okay, so now we need to just expand the brackets, and what do we end up with? So we end up with I2 plus, so minus, then I'm going to have a minus because I'm going to swap the limits. The first term will give me log x squared times f of x, which is precisely I2. So I get the minus I2. Then the next term will give me 2 times log x times I2 pi. So in other words, I'll get minus 4 pi I times log x times f of x. So that gives me I1. And finally, the last term would be this thing squared. So that's 4 pi squared with a minus sign. I've also got a minus sign coming from this. So I get a plus 4 pi squared I0. And okay, so obviously this thing and this thing cancel out. So I end up with changing the sign, minus 4 pi squared equals minus 2 pi I times the sum of the residues of f of z log squared z at the various poles. Okay. Now the trick here is to notice that, well, presumably f is going to be real. That means I, n are all real. So this I1 is real, this I0 is real, which means that we can take, if we want I1, we can take imaginary parts of both sides. Then this disappears, and we just want the imaginary part of this expression here. Now, because the residue is composed of a real part plus an imaginary part, if you think about it, if we want the imaginary part of this, it's simply going to be the real part of the residue multiplied by minus 2 pi. So we end up with, taking the imaginary part, we end up with 4 pi I1 is equal to simply minus 2 pi, the real part of the sum of the residues, or to give the final expression, I1 is equal to minus a half times the real part of the sum of the residues of fz log squared z at the various poles. So just to say, this formula here is not something you should try to memorize. Very bad idea to memorize things like this. it's straightforward to derive. You just need to remember the trick that when you get this expression here, then you think, okay, I can take imaginary parts, and then I don't need to work out what I0 is.